All right, let's dive right in. Today, we're talking about something huge, how we actually power the AI revolution. It's one thing to build these incredibly smart models, but it's a whole other challenge to get them out to millions of people efficiently. So let's get into it. This is the question, isn't it? It's the multi-billion-dollar question every single company in the AI space is trying to answer. So you've spent all this time and money on a groundbreaking model, but now what? How do you get it into the hands of your users in a way that's fast, reliable, and doesn't completely break the bank? Turns out the infrastructure is every bit as important as the algorithm itself. So, what's the perfect world solution? Well, for a lot of folks, it's what we call the serverless dream. Just imagine a world where you can deploy your AI model and that's it. It just works. It scales up to handle 1 million users, it scales down to 0, and you don't have to manage a single solitary server. It's the ultimate promise of the cloud, right? And this dream is built on some really amazing promises. First, pay-per-use. That means you stop bleeding money on expensive GPUs that are just sitting there doing nothing. Then there's automatic scaling, which handles those crazy, unexpected traffic spikes without you even breaking a sweat. But maybe the biggest win, especially for developers, no server management. They can pour all their energy into making the AI better, not into being a systems administrator. I mean, it sounds absolutely perfect, doesn't it? Well, you knew it was coming. This is the point where that beautiful dream comes crashing headfirst into reality. See, when you're dealing with the kinds of massive, power-hungry AI models we have today, I'm talking about large language models, that simple, elegant serverless promise, it starts to show some really serious cracks. The reality is, a lot messier. So let's meet villain number 1 in our story, the dreaded cold start. Here's how it works. In the serverless world, to save money, if a function isn't being used, the platform just shuts it down. Makes sense. But when a new request comes in, it has to spin everything back up from scratch. It's got to load the model, get the environment ready, and for a tiny little function, that's no big deal. But for a giant AI model, that delay isn't just a hiccup. It can be seconds long. And in computer time, that's an absolute eternity for a user just waiting for an answer. And honestly, this analogy just nails it. Imagine ordering a pizza, but before the driver can even leave, they have to literally build their car. They're assembling the engine, bolting on the wheels, filling it with gas, all while you're waiting. By the time that pizza gets to you, you're starving and you're probably pretty annoyed. That's a cold start. And for real-time applications, it's a total deal breaker. But oh, it doesn't stop with cold starts. You also have what are called bursty workloads, these sudden, unpredictable traffic jams that cause everything to slow down. Then there's a huge problem with resource inefficiency. You've got these incredibly expensive GPUs, and a lot of the time they're just sitting idle, but you're still paying for them. And finally, a big one, serverless is stateless. It basically has amnesia. It forgets everything after each request. That's a massive problem for complex AI that needs to remember the context of, say, a long conversation. But okay, it's not all doom and gloom. Far from it. Because if there's one thing the engineering world loves, it's a really tough puzzle. And some of the smartest people out there are coming up with some seriously clever strategies to bridge this gap between that serverless dream and the tough AI reality. Let's take a look at their battle plan. I love this because it lays out the strategy so clearly. To fight those bursty workloads, some systems are smart enough to group requests together. For models that are just too big to handle, other frameworks are actually splitting them into smaller pieces that can run at the same time. To stop wasting GPU power, there are new techniques that let multiple models share a single GPU's memory. And to make the whole thing more efficient, some platforms are even creating performance profiles to automatically pick the perfect, most cost-effective hardware for any given job. It's a full-on, multi-front war against inefficiency. And underlying all of this is a really fundamental shift in philosophy. For years, the standard has been reactive scaling. We wait for the traffic to show up, and then we scramble to add more resources. We're always a step behind. The future, though, is predictive scaling. It uses AI to actually forecast demand and get resources warmed up before the users even arrive. It's really the difference between reacting to a fire that's already burning and just preventing it from ever starting. Okay, so that's all the really cool cutting-edge research. But what are developers and companies actually doing right now on the ground to deploy these massive models in the real world? Let's open up the practitioner's playbook.
This quote from Susie Compton over at Salesforce, it just gets right to the heart of why many companies choose not to use a fully managed, hands-off serverless platform. When you're dealing with sensitive customer data or your own secret sauce models, control is everything. And that pushes a lot of people towards self-hosting, where they get the final say on security, on privacy, and on performance. The first method, and maybe the most tried and true, is the good old virtual machine, the VM. You can think of this as giving your AI model its very own private, dedicated computer up in the cloud. And the reasons for doing this are pretty compelling. You get total isolation, which is fantastic for security. You get a perfectly reproducible environment, which is absolutely crucial for getting consistent results from your model. And the big one, you get complete and total control. You decide everything. Plus, it plugs in perfectly with existing tools and awesome libraries like VLLM, which has really become a go-to for high-performance inference. Now, the second major strategy kind of takes things up a notch. Instead of managing a bunch of individual VMs, a lot of teams use Kubernetes, which is pretty much the king of managing containerized applications. And specifically for AI, there's a project built on top of it called Kserve. And the real beauty of Kserve is that it acts like a universal translator for serving models. It doesn't care if your model was built in PyTorch or TensorFlow, or if it uses a specific server from Triton or Hugging Face. Kserve creates this common, standard way to deploy, manage, and scale all of them. It brings a sense of order to the wonderful chaos of the AI ecosystem. So we've looked at the dream, we've faced the reality, and we've seen the solutions people are using today. But where is all this headed? This field is moving at an absolutely blistering pace, so let's take a peek at the next frontier of serverless AI. Let's be honest, the single biggest challenge, the one that's pushing all of our infrastructure to its absolute limits, is serving large language models. Their sheer size, we're talking tens, sometimes hundreds of gigabytes, makes every single problem we've talked about, especially cold starts, about 10 times worse. These models are the ultimate stress test for any system we can build. And this is where the most mind-blowing innovation is happening right now. We're seeing new frameworks that can cleverly pack thousands, yes, thousands of different fine-tuned models onto the same GPU. We're literally using AI to manage AI, with machine learning making smarter scaling decisions than any human ever could. We're pushing models out to the edge, closer to your phone or computer for better speed and privacy. And some are even looking at things like blockchain to create a trusted, verifiable record of AI decisions. The future is, well, it's going to be wild. And that really leaves us with this one final critical question. The AI models are getting bigger and smarter at this insane exponential rate. Our infrastructure is getting smarter too, for sure. But is it getting smarter fast enough? The race is officially on, and the outcome of that race is going to define the next decade of artificial intelligence. Thanks for joining me.